Hello and welcome to this Excel tutorial on measuring yields. This is the part one of two. Here we're going to look at Solver and how you can use it kind of in portfolio valuation. So this is Fibonacci chapter 3, measuring yield. It's on page 43 through 44. Here we're going to look at one specific yield measure, which is the internal rate of return or portfolio return. This is in the same section of the book that talks about all the different yield to put, cash flow yield, yield to worst, yield to call, current yield, and yield to maturity. So they all have their downfalls, but we haven't gotten to total return yet. That's the one that you use most often. But here's just kind of a simple way to look at internal rate of return. So this is I guess valuation 101. We know the market price of the security that's given here. It's 57.259 million, but we don't know what discount rate makes the present value of the cash flows equal to the market rate. So we're going to use Solver. So just a quick peek at what this actually is. Here we have a portfolio made up of 3 different bonds with 3 different maturities, and these are the cash flows for the bonds. So in year 1, or for the portfolio, in year 1, bond A brings in 350,000, bond B, 1.05 million, and bond C 900,000. So the portfolio cash flows for that year are just the sum of those 3, and that's the same for all of the cells below that. You can see these mature in years 6, 10, and 14. So this cell, these cells right here are the present value of the cash flows. Right now we're taking cell G14, which is the cash flow, divided by 1 plus the discount rate, which is a absolute reference because we have named the cell discount rate. And then we're taking that to the nth power, which is B14, which is the year in this case. And you can just drag that cell down, and then this cell right here is the present value. It just sums all of those present values. So as you can see, all of these cells, and therefore this cell, is determined on the discount rate. So right now we're saying, well, we think the discount rate for a portfolio with this risk is probably 5%, but that would make the market price wrong, so we know that our discount rate is probably wrong. So one way to do this, which is everyone's least favorite word, is guess and check. So we could, rather than 5%, we could do 4.5. Because we're 5%, you see, it makes the present value too low, so we know that therefore the discount rate needs to be lowered so that the present value will go higher. So we try 4.5, and that brings us to 58 million. So we know that's wrong. So you have to go through all of this, and you can get close, but you'll never know exactly the right number. You will, but it will take you too long. So we're going to use a thing called Solver. So it's under the data toolbar, and it's under the analysis section, Solver. If you don't have that, go to the Excel ribbon, Excel button, press Excel options, and go to add-ins, and go to manage Excel add-ins, press go, and just make sure you have all 3 of these checked. Press OK, and it should be there. So we're going to press Solver, and I'm just going to get rid of all this stuff so that we start fresh. Okay, so the target cell in this case is the cell that we want. Solver solves like a 2-sided equation, or any equation for you. So we know that on one side of the equation, the present value should equal the sum of all these cash flows at a discount rate. So this is the one side of the equation. Set the target value cell, we'll say present value, equal to a value which is the actual market, value. And the bad thing about, or the downfall of Solver, is that for this part you can't click a cell, so you have to type it in by hand, and it is the only place really where you can mess up. So just be careful every time you do that. And so we want to set the sum of all the present values with a certain discount rate equal to the market price, and we're going to change our assumption of the discount rate. So that's D7, and you see we named all these cells, so D7 turns into discount rate because we named it. And you can add different constraints here, so we could say, oh well, we never want the discount rate to be less than 0, so this is saying D7 always has to be greater than 0. Just press OK. So now we have everything we need. We just press solve, and as you can see, 4.5 wasn't right, 5 wasn't right, 4.85 wasn't right, and then it found that 4.77 was the correct discount rate. So in the homework it says to make sure you click these 3 reports, and although it doesn't really help you out that much for this simple solver example, more complicated ones, you can look through the answer report, the sensitivity report, and the limits report. Remember, this naming section here is the reason that we have to name cells. So rather than just saying D7 and then it would say D7 again, it says discount rate, so you know kind of what your data is. So this is part 1 of 1, and the next video is part 2 of this is part 1 of 2, and the next one is part 2 of 2, looking at scenario inputs.